This video will show how to use the spectrophotometer to measure the amount of absorption in dilutions. A copper mean solution will be used during this lab.
We're now going to transfer the solution into the cuvette. We're going to take a bit in our pipette here, and we're going to fill it up to the line. We're going to repeat these for all of our dilutions and the water and the stock solution. We have all our cuvettes. We're going to head over to the spectrophotometer to test the absorbance values.
We are now cleaning the two sides of the cuvette with a Kim wipe so that the light may pass through.
To start doing our spectrophotometry lab, we're going to first blank out the machine. And then we're going to insert our stock solution in order to scan across all wavelengths. This is because we want to use data with the higher lambda max, which is a higher point of absorption, which allows us to have higher sensitivity for our experiment. Lambda max is the point on the graph where the substance has the most absorption.
In this clip, we set the correct wavelength at 625 nanometers.
Now,
we put water into the spectrophotometer as a blank to 0.
Wait, what? Okay. Oh, 625. 625, and I click 0. It has zeroed out. Do I click it again? Why did I negative 0.001? It said at or close to 0. Yeah, okay. Yeah. So we zeroed it, now we're good, and
Here we put our first dilution into the spectrophotometer to measure the absorbance level.
and then just press read.
it doesn't lock to it. Oh, it doesn't lock to it. It's just the general.
Okay,
No, it has to be a whole number, right?
This is a video of our second dilution being put into the spectrophotometer to look at the absorbance.
Oh, doesn't this have to go in? Doesn't this arrow have to go in this direction? I don't know. It does. Well, which direction?
yeah, yeah, you're good. Agreed.
At the end of the lab, we clean up by pouring all our reactants and products down the sink, washing all our containers, and leaving our lab bench clean and tidy.
We began by calculating the molarity of our stock solution. We placed 0.125 grams of copper sulfate pentahydrate in the volumetric flask and did grams to mole stoichiometry using the molar mass of copper sulfate pentahydrate, arriving at 0.005 moles. We knew the formula for molarity is moles divided by volume in liters. So, to calculate the molarity of the stock solution, we divided our moles of copper sulfate pentahydrate by the 0.025 liters of solution we got when we filled the volumetric flask to the mark, arriving at a stock molarity of 0.02. Next, we used our stock to create our dilutions and calculated the dilution molarities as well. We began by calculating the molarity of our first dilution using this formula, in which MS and VS are the molarity and volume of stock solution transferred, and MD1 and VD1 are the molarity and final volume of dilution 1. We transferred 0.00973 liters of the 0.02 molarity stock solution to the volumetric flask and filled to the 25 milliliter mark. Since we were trying to find the molarity of dilution 1, this remained a variable. We then multiplied and divided to solve for MD1 and arrived at 0.007784 molarity. We then used this value in the same steps to calculate the molarity of dilution 2, and then used the molarity of dilution 2 to calculate the molarity of dilution 3. We then collected these molarities onto a table and took our stock solution dilution and unknown cuvettes to the spectrophotometer, giving us these absorbance values. We then plotted these values onto a graph and got the equation to the lines using Excel. With this equation, we plugged in 0.0212 for y and solved for x, or the concentration of the unknown, giving us negative 0.00227 molarity. Since this value was negative, we knew our measurements must have been slightly off, since it's impossible to have a negative concentration. When discussing spectroscopy, it is also important to discuss Beer-Lambert's law, which states that the amount of absorbed light is proportional to the solution concentration. There are two main formulas associated with Beer-Lambert's law. Since both formulas are equal to absorption, you can set them equal to each other to get this formula. Then, if you rearrange it, you can solve for the concentration.